So in our last video, we explored modular arithmetic. And in this last video, we're going to do some practical modular math for clocks. So, first we want to introduce some notation that relates to the division algorithm. So remember the division algorithm. So if you have an integer a, sometimes called your dividend, and a positive divisor d, where a equals dq plus r, right? A equals dq plus r, that's your equation for your division algorithm. And remember, for the division algorithm to be correct, the remainder r has to be greater than or equal to 0 and strictly less than d, the divisor. So if that happens, if you have the division algorithm set up, then sometimes we call the quotient q here, we call that a div d, and I'm going to underline the div. Now the reason I'm underlining this is because textbooks, they bold this. They write this in bold notation. I don't have a way to write this in bold notation, so I'm going to underline the div to indicate this is bolded. So the quotient you'll see times is a div d. And the remainder r, you'll sometimes hear it called a mod d. So don't confuse this with the triple bar congruence relation. This is not the same thing as the triple bar congruence relation, modulo m. So these are two notations you'll see. The quotient is a div d, and the remainder is a mod d. Okay, so we're going to use that. So I want to work a few problems, some exercises. Involving clocks. So number 1. Where'd my marker go? There it is. What time does a 12-hour clock read? A, 202 hours after it reads 3 o'clock. So the idea is you're starting at 3 o'clock on a 12-hour clock. So what's a 12-hour clock do? It goes around to 12, and then it goes around to 12, so it has rotations of 12. So we're in a mod 12 system. So I'm starting at 3 o'clock, and I'm going forward 202 hours, right? I have to add 202 hours to that. So I want to mod this by 12 to figure out what time it will be in 202 hours. So I take 3 o'clock plus 202 hours and mod this by 12. So what does that mean? Well, 3 plus 202 is 205 mod 12. Now remember what this means. 205 mod 12, this is the remainder that you get when using the division algorithm. Okay, let's break out our division algorithm on the side. So you're taking 205, dividing 12 into it. You're going to get a quotient plus a remainder. So how many times does 12 go into 205? So I got 205 divided by 12. That's 17 times. So my quotient is 17. And I'm going to take 205 minus 12 times 17 to get my remainder. That's going to give me a remainder of, I got a remainder of 1. Yeah. So my r is 1, so this is equal to 1. So 202 hours after 3 o'clock is 205 mod 12, which is simply 1. So that would read 1 o'clock. Now whether it's AM or PM, we can't tell from this information. We're just doing a clock. Remember, when you're looking at a a clock, you can't tell just by looking at a 12-hour clock whether it's AM or PM. So 1 o'clock. 1 o'clock. All right, let's do another. Let's do 336 hours after it reads 8 o'clock. Oh, not after. I am sorry. Before. Ooh, we're going back in time. Back in time to the past. So we're not going forward in time, we're going back in time. So that's quite a bit different. So here's the idea. You're starting at 8. And you're going back in time, so you're going to have to subtract some time. 336 hours to be precise. And we want to look mod 12 because we're dealing with the 12-hour clock. So what is 8 minus 336? 8 minus 336 is minus 2 minus 328. So minus 328 mod 12. So that's going to require some division algorithm. So let's do that on the side, the division algorithm. Whereas we take minus 328, we're going to divide 12 into it. We're going to get a quotient and a remainder. So we're going to take negative 328 divided by 12. You get negative 27.3333. Remember, use the floor function, so you get negative 28 for your quotient. And your remainder, R here is, well, let's take negative 328 plus 12 times 28, and you get a remainder of 8. So the remainder is 8. So it's 8 o'clock. Wow. This is equal to 8. So 8 o'clock. So the idea here is when you're doing the division algorithm, you get a quotient of negative 28. A quotient of negative 28. So that means you're going back 28 rotations of the clock. So you go back 28 rotations of the clock. That's what 336 hours would be before. It would be negative 28 rotations of the clock. So back 28 rotations of the clock, going backwards, and you would end up at 8 o'clock. All right. So the Q is actually the number of rotations that would occur. Okay, so those are some 12-hour clocks. Let's do some military time. Military time is a 24-hour clock. And the military time's nice because you can tell exactly if it's AM or PM, right? If it's before 12, it's AM. If it's after 12, it would be PM. Let's say 16 o'clock, right? 16 o'clock would be like 4 PM in the afternoon. Okay, so some military time. What time does a 24-hour clock read? Part A, 314 hours after it reads 1600. Okay, so we're starting at 1600, right? And we're going forward in time. So we have to add 314 hours to 16 hours. So 16 plus 314, we're going to mod this by 24. Right, we're on a 24-hour clock, so a 24-hour cycle is 1 day, so we're mod 24. So, okay, what's 16 plus 314? That's 330, right? 330 mod 24. So division algorithm comes out. Our remainder will be our answer. So division algorithm. So we take 330, divide 24 into it. We get a quotient plus a remainder. And my quotient is, let's see, 330 divided by 24 is 13. plus a remainder of, let's see, 330 minus 24 times 13 is remainder of 18. So the quotient was 13 and the remainder is 18. So this is equal to 18. So it would be 1,800 hours of military time. Or 18:00. So what is this saying? This says basically 13 days go by. So the quotient here is not the number of rotations, it's the number of days, right? A 24-hour cycle is a day. So 314 hours after 16 o'clock would be 13 days later, and then it would be 1,800 hours in military time, 18:00. That would be 6 p.m., basically. But we want to write it in military time, 1,800 hours. All right, B. So still dealing with a 24-hour clock. We want to look at 1,001 hours before it reads 2 o'clock. This is military time again, 200. They sometimes call that 200 hours when they say 2 o'clock. All right, so we're starting at 2 o'clock, and we're going backwards in time, so we're going to have to subtract 1,001, and then we're going to mod that by 24 hours. We're on a day cycle now. So 2 minus 1,001 is going to be negative 999 mod 24. So division algorithm comes out. So minus 999 equals 24 times a quotient plus a remainder. Let's take minus 999 divided by 24. You get about negative 41.65. Let's use the floor function to get negative 42 here. So the quotient is negative 42, and the remainder is, let's take negative 999 plus 24 times positive 42. I get a remainder of 9 here. So here my answer is going to be 9, or you could say 9 o'clock. So the interpretation is you're going back 42 days into the past. So when you have a minus 42, that means you're going back 42 days in the past, and it's 9 o'clock. That's the interpretation. All right, well, there we are for section 4.1.